In this lesson, we'll be looking at inequalities, and this is really a review of what you would have learned in an algebra course. And so we'll start off with the properties of inequality. There's really, we're grouping a couple of these together, the addition and subtraction property of equality. You can add or subtract any number from both sides of the inequality, and it will still remain true. And so as you can see here, we have A is greater than B. A is greater than B, and you can add C to both sides. So you added the same thing to both sides of that inequality. The next one here is A is greater than B, and C is greater than 0, which means C is positive. Then you can multiply C to both sides and things remain true. But on the second part of the multiplication property, also with division, A is greater than B, but C is less than 0, or it's negative, so then AC is less than BC. The way that we've said it before is if you multiply or divide both sides of an inequality by a negative, you must switch the inequality. And then the last one is the transitive property. A is greater than B, B is greater than C, so therefore A is greater than C. And so those are the different properties of inequality. We're also going to look at graphing different inequalities. So here are some rules that we learned. When using a greater than or a less than sign, so no or equal to parts, draw an open circle around the number. This means that the graph does not include that number. So you'll use an open circle if you have a greater than or a less than sign. You'll use a closed circle. You close the circle because that graph will include that specific point. When you're using greater than or equal to and less than or equal to, you'll color in that circle. Compound inequalities, those are using the words and or. And means intersection. Include in your solution where the two graphs overlap, so where one is on top of each other. And means that both things have to be true. And then we'll see or, that means union. That includes any portion that either of the graph covers. Maybe both graphs cover it, maybe just one, but anything that's covered is part of your solution. And so here we'll look at a compound inequality graph. X is greater than or equal to 3, or x is less than 2. So here's a number line. We'll graph both parts above the graph. This is what I want to see. I want to see you graph both things above the graph. So closed circle around 3 and an arrow to the right because x is greater than or equal to 3. We use the closed circle because it's got the or equal to. And then an open circle around 2 and an arrow to the left to indicate x is less than 2. Now, you do not just circle this. This is not your answer. You must put your answer on the number line. And so here we have an or. And so since it's or, we're going to just look, we're going to put our solution on the number line, whatever's covered. And so we notice that those parts are covered there. So it's anything on the graph that's covered, and so this stuff is all covered. Sorry. And the part to the right is all covered too, so that's our solution. That's how you graph the solution. Well, now it's the same inequality, except that there's an and in between, so we're going to start off the same. We're going to graph both above, and greater than or equal to 3 is above there with a closed circle, less than 2 has a closed circle. And now we're looking for where those two inequalities overlap, and we notice that they don't ever overlap, and so the answer for this one is no solution because they don't overlap. So we'll put no solution, empty set, or null set. Nothing makes both of those true. So going back to the original, there is no number that is both greater than or equal to 3 and less than 2, which I think is probably obvious to us that a number can't be greater than 3 and less than 2 at the same time. And here we're going to look at absolute value. the absolute value of x is less than 3. So if we remember, absolute value means a distance from 0. So we could read this, all values that are at a distance that is less than 3 units from 0. So we want all values that are within 3 units from 0. Now this is a less than sign, not less than or equal to, so we have open circles, and now we want all values that are closer to 0 than 3, and so that's on the inside here between those 2 points. So that graph there represents all values that are a distance less than 3 from 0. Here's a definition of greater than. We'll use this a little bit in the future when we're dealing with some rules that deal with inequality. And so this isn't how we normally think of greater than, but this is a good way to think about it and a good way we can put it into an equation or an inequality. So a real number a is greater than a real number b, and so a is greater than b, if there is some positive real number c, so that a is equal to b plus that positive number c. So if you can take b and add some number to it to get a, some positive number to it to get a, then a is greater than b. And so here's an example. I know the answer is there right away. It says show that using the definition of greater than, that 9 is greater than 5. So we're looking at this definition here of greater than, and it says a is greater than b if there's some positive real number c, so that a equals b plus c. So we found a positive number 4, so that 9 is equal to 5 plus that positive number 4. So that's how you would show that using the definition we just learned.